This is a worked example on how to graph absolute value functions. So anytime we're working with an absolute value function, especially when we're graphing, but this is a good rule of thumb for anything, we always want to change it into its piecewise definition. So the original piecewise definition, before we even apply anything, looks like, and that's an ugly bracket, let me redo that, looks like the absolute value of x, and then it's going to be negative x if x is less than 0. It's going to be positive x if x is greater than or equal to 0. Now, we can go ahead and apply our equation to this formula, but we want to be a little bit careful when we do so because it can be easy to mess up. So we have instead x plus 4 instead of just x. And so when we go through and define our piecewise definition, we actually can replace every instance of x with x plus 4. So it'll now be negative x plus 4 if x plus 4 is less than 0. And it'll be x plus 4 if x plus 4 is greater than or equal to 0. So you're going to replace in every instance, even with the inequalities, and now we can go through and sort of do the algebra and make things look nicer, right? So I can start by distributing that negative sign in x plus 4, so it's negative x minus 4, and then I'll actually fill in the bottom row too while I'm at it, so we have two ifs. And then we can actually also adjust the inequalities, so x plus 4 less than 0, well, I can subtract that 4 over and say that this happens when x is less than negative 4. And same thing for the bottom. It's the exact same calculation, we just have a different sign. So the completed piecewise function is negative x plus 4 if x is less than negative 4, and x plus 4 if x is greater or equal than 4. Now that we have this information, we can go ahead and draw this on a graph, and we're actually just going to graph two straight lines. So if I could draw my axes properly here, okay. And let me give myself some tick marks as well. And so now we're just going to go through and graph two lines, and we're just going to do that based off what the piecewise definition gives us. So the first thing that can be useful to do is we can sort of differentiate between where the two parts of the piecewise function are happening. So we can see that negative 4 is the point at which things are changing. So perhaps I want to mark at negative 4 just a straight line, so I can sort of say to myself, okay, this is where things are changing. And this line is not exactly straight, but it's not a huge deal because I'm actually going to erase it later. So to the left side of x minus 4, we can graph one line, and so I'll circle it in blue because I'll draw it in blue. So I have a negative x minus 4. So I know that y-intercept, excuse me, the y-intercept is occurring at negative 4. So we'll draw that in here. And then if we think back to the last worksheet, which was linear functions, we're looking at rise over run, and we have a negative x, and so I'm going to have like a negative rise over a negative run, but it's just going to be a perfectly straight slope of 1 going downward. And so we're actually 4 tick marks downward, and we're 4 tick marks over. So this line is actually going to perfectly intersect with that point 4. And I would like to be able to draw a straight line if I could. There we go. Okay. So it's going to perfectly intersect, 4 ticks down here, 4 ticks over here. Okay. Next, let's graph x plus 4. And so what we have here is that we're going to be going up 4 units. So, actually, before I do that, let me make sure I do one more thing. You want to keep in mind that this x minus 4 function is only able to take place when x is less than negative 4. So this side of the line, or if I could, this side of the line right here is actually not going to show up in our final picture. And so I'm going to erase it. Now my computer will erase the whole thing at once. I'm going to redraw the rest of the line here. So you want to make sure you're erasing the correct portions, because this blue part of the line can only exist, again, when x is less than -4. Okay, now let's go ahead and finish the picture. So we have x plus 4, same thing. We have a y-intercept happening at +4, and then we have a 1-to-1 rise over run. So this is also going to intersect directly with this point. Whoa, I don't want it to jump like that. There we go, okay. Now, keep in mind that if I drew this entire line, it would actually keep going in this direction. I don't know why it's popping up. It would actually keep going in that direction, but remember, this green line can only exist when x is greater than or equal to -4. And so we actually also want to erase that part of the green line. So you want to make sure you're erasing depending on what goes where. And then to finish it off, we can just erase the guideline we drew. And then if we want to add some arrows just to indicate that these lines will go on forever in those directions, that's what graphing a piecewise function might look like. So again, just to recap, you always want to turn it into piecewise form, because it can be a lot easier for you to understand how to graph it if you can understand how to graph a linear function. And then it can be very helpful, especially if you're using pencil, to draw some guidelines, draw more lines than you need to, because you can always erase them later. If you're using pen, okay, be a little more careful, but really all that an absolute value function is just graphing two straight lines. You don't got to overthink it, just change it into that piecewise form and you will do just fine.